First up, partition elimination. This magic partition elimination we hear about. We're going to talk through an example with an example table. Our example table contains keywords. So imagine we have a system where we're running some advertising and we let people set up campaigns maybe to advertise on search engines. So we have a table that has keyword ID, which is a big int column. So every keyword in this table gets its own unique keyword ID. And we have that as our clustering key at first before we partition the table, a unique clustering key. We also have a customer ID and then advertiser ID and campaign ID, because a customer can have multiple advertisers and advertisers are going to have multiple campaigns. And we have a keyword and we have some date columns just about when the data went in the table and when it was modified. If we want to partition this table, let's say we decide, I want to partition this table by customer ID. And I set up this example on purpose this way. Certain tables are more natural to partition than others. Imagine we had a table that wasn't just, okay, what are our keywords set up, but what is historical data on how many clicks each keyword got, right? And we're going to have a date time column about when did this click happen. On a table like that, it would be like, say, in a warehouse, in a reporting system where what we're doing is keyword clicks is the nature of our table by that column of when did the click happen. It would be pretty natural to partition that table by the date time column because we're going to have data coming in when we get the data for the clicks and maybe partitioning by, depending on how much data we collect, how big of a click, search engine we are. Maybe we're partitioning by day, maybe we're partitioning by month, maybe we're partitioning by hour, right? But different columns will be natural. In this table, we might want to say all of our queries against this table tend to be specific to a customer. So we want to partition this table by customer ID. Now that's kind of tricky because we may have some customers that don't do a lot of business with us and some customers who do a huge amount of business with us. So our partition size may be lumpy and we can't do partitioning this way. It can just be a little bit tricky. But so let's say, for example, we're partitioning on customer ID. We can make that our partitioning key, but our partitioning key does need to be in our clustered index. We can still have keyword ID as the leading column in our clustered index. That is still allowed, but we need to at least put customer ID in that key. So it needs to either be first or in this case, second, since we only had one column in there. So we say, okay, we want to partition by customer ID. So we're going to keep keyword ID as the initial key. As new keywords get generated, they get ever increasing keyword IDs, but we're going to put customer ID as the second part of that key. And that means that, keyword ID, we don't have a unique clustered index just on keyword ID anymore. So we have to make that change. All right, okay, so we did that and we're partitioning by customer ID. Now, what our clustered index of our table looks like is a bunch of little trees. Each customer ID now has their own little clustered index B tree. Here we have, for example, let's say we have customer ID 100, 101, 102, and 103. Each customer has their data in their own little tree. So as long as we are really always in our query saying, I want a specific customer ID, or these specific customer IDs, maybe a range, it's easy to just go to those individual customer IDs. That's kind of awesome, right? Well, let's look at some examples of this. Imagine some data in our clustered index, the table itself. And I have drawn these triangles of equal size. Of course, if we do have customers of different sizes, some of these triangles would literally be huge and some would be small. Our clustered index on the table by keyword ID, customers may have different periods where they just aren't doing work with us. They just aren't creating keywords. So within each customer, we know the order of the keyword IDs. But overall in the table, when we're looking at all of these different customers, they each have their own different range of keyword IDs. And we don't have an overall sort in the whole table. We only are sorting by keyword ID for the individual customers. We run a query. We say, I want to select a keyword where the customer ID is 101 and campaign ID equals 500. Now, campaign ID is not in the clustered index at all. But customer ID, it's the second column in the clustered index, but it is our partitioning key. Since it is the partitioning key, we can get partition elimination. SQL Server says, oh, one of the predicates in your query is the partitioning key of this table. So I can go straight to that partition. Now, campaign ID, it's not in the clustering key. So if I don't have a non-clustered index that leads on campaign ID, I am going to have to scan that whole partition and check. Okay, for every keyword in this, what campaign are you in? What campaign are you in? What campaign are you in? But at least I didn't have to scan the entire table. We were able to get partition elimination. So that's very, very cool. As long as I am specifying the partitioning key as a predicate in my query and I'm not having something like a bad type of implicit conversion happening, there are things that can screw up partition elimination. I can go straight to that partition and either do a seek or a scan in it. In this case, let's say this is a query that's run often and I do want it to be fast. I can create a non-clustered index and say, okay, I want to create a non-clustered index on campaign ID. And I'm even going to include that keyword column so that it rides along in the leaf of that index. If I use syntax like this to create the index, notice that I haven't specified to create it on anything. I haven't said go create it on this file group or go create it on this partition scheme. It will say, it will create this as an aligned non-clustered index. Unless I specify differently, it will create my non-clustered index as partition so that each customer has their own little chunk in this. Notice in this non-clustered index, I didn't specify the partitioning key. In a non-clustered index, it'll let that go through. It will just secretly put the partitioning key, it will tack it on like it does. I haven't in this diagram, I haven't noted that the clustered index key will be secretly put in there too, just for simplicity. The partitioning key will always have to be snuck in, right? And in this case, it is part of our clustered index key. Now to step back a little, you can actually partition a heap. It is possible to partition a table without a clustered index. Sometimes folks do that under certain situations where they know, hey, I'm always going to want this partition to be scanned. I don't have a useful key that I would want to use for lookups as a clustered index or anything like that. So it is technically possible to partition a heap. It's sort of rarely done. Often the main use I know for that is like if the table is sitting behind, say, an analysis services cube that needs to be fully reloaded every night, and we're going to be scanning the partitions, that might be useful. So even though in our non-clustered index, we didn't specify the partitioning key, it's going to end up in the key for our index. And this gets particularly interesting, by the way, if we want to create unique indexes on a single column. It'll be like, if that unique index isn't on the partitioning key, right? Like, hey, I've got a problem here. I've got to have the partitioning key in the key of your index. So in this case, if I wanted to create a unique index on campaign ID, which by the way doesn't make any sense in this table, but say I had a table where it did, it would be like, oh no, I can't do that as a partitioned index because I have to have customer ID in there. I'd have to do a special workaround, which we'll talk about in a minute. So in this case, I want just to be able to find campaign ID quickly, and I want to have access to keyword very quickly. So I create this non-clustered index, and I get a partitioned index for every customer within the customer, the data is sorted by campaign ID. So if I'm going to run this query, and I'm going to say, okay, for customer 101, for campaign ID 500, I want to know all the keywords. Now it can not only do partition elimination based on the customer ID, but I have a non-clustered index that leads on campaign ID so it can seek directly to that index. And that is awesome. I have a question from Diana. I have a huge table with a primary key that is a composite of transaction ID plus year plus category value. Can I partition on the data on year if it isn't a discrete column in the primary clustered index? Oh, that is an interesting one. So, okay, there's a couple parts to this. The way I can think of that you could do that, Diana, is a way I wouldn't recommend. Like you could potentially, like the partitioning key needs to be a single column. It is allowed to be a computed column. So in theory, well, not in theory. I mean, you could create a computed column that figures out what the year is in the compound key and creates it as a computed column. However, there are many, many problems with having a partition table on a computed column just with implementation. I have seen folks who've done it, who've been writing emails like, I'm getting all these bad query plans and I don't know why. And folks look at the query plans and it ends up being due to the fact that it is a computed column. So I wouldn't do it that way. If you can make some sort of coding change where you do have a discrete column that is not a computed column, yeah, so I would not, the way you can do it, I wouldn't go. So yes, you can do it. Folks have had a really bad time with that. Sorry about that. Complexity. Whenever we add the complexity in with computed columns, even persisted computing columns, there's a lot of problems with that, unfortunately. John says, we find a lot of instances where the partition key is not used initially. In this case, campaign ID is done first, causing all partitions to be loaded initially, and then customer ID is used. If the example was in this query, the order in which customer ID and campaign ID are specified in this query, if it was reversed, that should not matter. SQL Server, the order I specify the predicates in is not generally used because it will take all these things out and logically change them. Now, there are a couple exceptions to what I'm saying here. The exceptions don't tend to be with the order you specify predicates in. If I have a query that has, say, more than 7 joins, a large amount of joins in it, periodically, the order in which I specify the joins may make a difference in the query plan, simply because the optimizer tries to optimize queries as quickly as possible, and it may take different paths in how it explores that optimization tree based on the order in which I have my joins. I personally haven't seen that happen when it comes to the order of predicates in a where clause, but if it was something with join order and you have a lot of joins, sometimes I've seen the order they are listed make a difference. But like for this very simple query where I just have 2 predicates in the where clause, I can reverse these and it should not impact my query plan. If it did impact my query plan in a query like this, I would want to, file a request and be like, hey, why is that making a difference? Because it shouldn't make a difference, the order in which I specify this predicate. I've shown how partition elimination is really cool, but let's step back and say, what if we didn't partition this table? Okay, I've got this query that has predicates on customer ID and campaign ID. If I am just going to index that and it's not a partitioned index, I could create an index on keywords and say, okay, my 2 predicates are customer ID and campaign ID. And in this case, I have 2 equality predicates on them. It shouldn't even matter what order I put the columns in this index, in this case, because they're both equality predicates. I'm going to create an index on customer ID and campaign ID, and I'm going to include the keyword column. So if I create this as not partitioned, either on a table that isn't partitioned, or if I have a table that is partitioned, I can actually create the index by saying, create this index, and then at the end of the create index statement, I say create it on a file group name. I'm saying don't create it on the partition scheme. Create this somewhere else. Now I just have a single big tree. It's not partitioned. And I have cut everything ordered perfectly, first by customer ID, then by campaign ID, and the leaf of the index also includes the keywords. Now, I am not getting partition elimination when I run this query, but I don't need it. I can just seek straight to the rows. Partition elimination is a useful thing, but if I'm not partitioning an index, I can make it really fast just by designing the index well. And it's not like this index is bigger because I had to specify customer ID in the index. No, in the partitioned index, customer ID was getting added in there, whether I specified it or not. So the partition elimination is helping that modified structure, but my performance without the partitioned index isn't bad as long as, either way, whether the table is partitioned or not, if I'm doing index tuning, I can make it fast. So it's not like partition elimination gave me magic. And there can be some trickiness.